and then put it down.
Without it going.
Is it level?
Yeah.
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 Enough.
Yeah.
It doesn't. All right. So welcome guys. Today we're doing 9E. We'll start with 9E. So we've got sample proportions. All right. So we'll get straight into the example and we'll talk about what the observed value of p hat is versus the population value. So just remember when we have a mean and standard deviation, that's for a population. So I can put here population, and we would use, for the sample, the notation we would use would be x bar and s for the standard deviation. Okay, that's for a normal distribution. What we're looking at today is a proportion. So let's get to our example and it'll be pretty clear to you what a proportion means. So we have a sample of 10 people finds that 3 of them have blue eyes. Find the observed value of p hat. Call it p hat. So p hat is the observed characteristic divided by the number of people. So this is 3 out of 10 or 0.3. All right, it's a proportion of people that have a particular trait. Okay, this is our observed value. And just like, so this is based off of a sample, p hat is based off of a sample, and it is indicative of some property of the population, some proportion of the population. So we use p for the population and p hat for the sample.
So P be 10 with 10 people.
Sorry, I didn't hear that.
Would P be 10 because 10 or?
No, the number of trials is 10.
Oh.
Yeah. The population is all people. Yeah, and we've got a sample size of 10 people, where 3 out of 10 of them had blue eyes. Okay, state the observed value of p hat done. Part B, find the mean and standard deviation of p hat. So those are listed in the second sentence. Given the population proportion p sample size n, the sample proportion p has mean p and standard deviation this. So if we're not given a value of p, we assume p hat is indicative of it. So our question is, part B, find the mean of p hat. So the mean of p hat is 0.3. And the standard deviation, we have that formula there, is the square root of p times q. Now q is the inverse proportion, right? Proportion of people who don't have blue eyes divided by the number of samples. Okay. And then we have the question, is p hat normally distributed? So just like the central limit theorem, for sufficiently large n, we can say that a proportion will be normally distributed. And the criteria that it has to satisfy is listed at the bottom. N times p is larger than or equal to 5, and n times q is larger than or equal to 5.
Oh, Mr. Rogers, we have to solve for the...
Oh, yeah, we should, yeah. So, has anyone typed it in?
0.145.
Cool. Alright, so we have a mean and a standard deviation of p hat. Okay, is p normally distributed? So, the way we check, we go, is n times p greater than or equal to 5? And is n times q greater than or equal to 5? So if we do n times q, 10 times 0.7, that gives us 7. 7 is larger than or equal to 5, so it passes this test. Tick, we've passed the first test. We need to check the second test. N times p, so that's going to be 10 times 0.3. That gives us 3. It is not larger than or equal to 5. It fails this test, therefore p hat is not normal. Or maybe what we should say, sorry, is that n is not large enough for p hat to be approximately normal. Let's say that. N is not large enough for p hat to be hat to be normal. Okay, because like the central limit theorem says, the larger the value of n gets, the more normal the distribution that arises will become. Okay, so just a recap of three properties. We have a p hat is our sample proportion, p is our population proportion. Here we have 3 out of 10 people have blue eyes. Then we did the mean and standard deviation. Well, the mean is just the observed value of p hat. If we're given the value of the proportion, that trumps the observed value, just as when we were doing exercise 9b, we might have an observed mean, but the population mean will always take precedence over the observed mean. It's the formula for standard deviation, and then this property here will, if it satisfies both of those, we can say that it is approximately normal. Okay, so that's enough to get into 9e. Let's get started on that today.